my first topic of the evening is one of my all-time favorite techniques for dealing with large-scale software complexity, and that's feature flags. Now, you may have heard of feature flags under other names. They're sometimes called switches, they're sometimes called feature flippers, but generally the concept is exactly the same, and in my opinion, this is one of the highest ROI items that you can add to a code base. When we built these for Lanyrd, it took an afternoon to put in a basic mechanism for this, and we used it every day from then on, and it gave us an enormous amount of value. So really, what you're trying to get at anytime you're trying to build high-quality software is you want to obey the mantra of releasing early and releasing often. Until your software is in front of real human beings, you have absolutely no idea how they're going to use it if you're even building the right thing. This has been further popularized by the lean startup movement, which I stole this image from their website. They have this sort of cycle where you come up with an idea, and then you build it to create the product. Then you measure how people are using the product. You take the data from that, you use that to generate more ideas. And really the goal of any startup, especially if you've got a limited runway, is to race around that cycle as quickly as possible, make sure you're building the right thing. Now, if you want to build things, if you want to iterate quickly, if you want to build things fast, when it's just you and a greenfield development and a text editor, that's pretty easy. You can knock out features very quickly. But what we found with, so we experienced this firsthand with Lanyrd, as your product grows and as your development team grows, it gets much harder to build features and ship them. One thing we found in particular is every time you release a new feature, you have to think about the way it interacts with all of your previous features. So if it's your first feature, that's really easy. But later on in the development of Lanyrd, we released a feature called Guides, which allowed users to collect together a set of events as like my top Python events of 2014. And when we built that feature, we realized that before we released it, we had to figure out what that was going to look like on the users page and on the event pages and how it would work on our topic pages and how it would interact with our mobile apps. And every single feature we'd released previously was interacting with the new thing we were building. So feature development takes a lot longer. It's a lot longer to get it right. There's a lot more complexity involved. It's tempting when you're faced with a situation to use branches, to build a branch per feature, spend a bunch of time in that branch, and then merge it in when you're done. But long-term branches have a whole bunch of their own problems. You find yourself totally diverging from the functionality of the main site. Your new code isn't getting tested properly, and generally you set yourself up for all kinds of complexity at the last moment when you merge it back in and find out that there are conflicts and feature interactions that you haven't expected. So the alternative to this is to use feature flags. And most companies that use feature flags actually tend to work in a single main development branch. They'll spike off little feature branches for very short periods of time, but the aim is always to merge the new features into the branch as quickly as possible. Because what feature flags let you do is they allow you to expose features on your site to a subset of your user base. And at first, that might just be you yourself or the rest of your development team. You could then roll the feature out to alpha testers, onto beta testers, onto trusted customers, and eventually release it to your entire audience. And this has a whole bunch of advantages, including one in particular, which is that it means you can decouple the deployment of a feature from the release of that feature. You don't find yourself shipping a new feature and SSHing or pushing code up to all of your servers at once, crossing your fingers and hoping it all works. You can deploy the feature several days beforehand and then just turn it on when you're ready to put out your press release or do whatever it is you would do to release something. It also gives you risk-free instant rollback. If you turn the feature flag on and stuff breaks, you could just turn it back off again. So I'll talk you through a couple of implementations of feature flags. I'll talk about how we did them at Lanyrd, where we essentially rolled our own from scratch as a very simple system. And then I'll explain how Eventbrite does something quite a bit more comprehensive using an open source solution. So at Lanyrd, we had feature flags for all sorts of things, but fundamentally, each one was an identifier which is designed to be referenced from code, and then a human-readable description so we could tell what the thing was meant to do. So we had a setting with all of our feature flags in it, and then we store the feature flags in the database. There's not going to be a great deal of code in this presentation, but I figure everyone here probably knows what a Django model looks like. So this is a Django model for a feature flag. It has a unique slug, which is that short string. It has a description, and it's got a Boolean field saying if it's been switched on for all of the users of the site or not. Then we also have a many-to-many field against users, so we can select 0 or more users that the flag should be enabled for. And we have the same thing against groups, so we can turn on a flag for an entire group of users. And then the remainder of the implementation is one method that, given a user, tells you if the feature flag is enabled or not. So a feature flag is turned on if it's turned on for everyone, or if it's turned on for the specific user, or if it's turned on for one of the groups that that user is a member of. And believe it or not, this was pretty much the entirety of our initial feature flag implementation. Over time, we evolved it a fair bit. We added caching to make sure that it wasn't going to completely clobber our database. And we added quite a few helper methods to make it really easy in code to use these flags. This is our first helper method. This is a view decorator. You can stick it on any view function that makes up your website. And all it says is that this view function is only available if the user has the topic tracking feature flag. If they don't, we serve a 404 error because we don't want people guessing URLs and sniffing around on a website trying to figure out what we were going to release next. We have a method on a user saying if user has flag topic tracking, and then you can have code level switching between the featured version and the non-featured version. And we also added feature flags into our template language. We had a custom tag where you can say, if the new Eventbrite flag is on, this is actually the feature flag we used when we announced the acquisition, because we wanted to make sure that we put the press release out, and then an Eventbrite company logo appeared all over the site simultaneously, so we could flip on a flag and add that into our footer. We did add one more feature, one more template flag, because we found that we had a whole bunch of trusted alpha and beta testers, but we turn on features for them, and sometimes they wouldn't have read the email saying this was a test feature, and they get excited and start tweeting screenshots of something that we weren't ready to release yet. So the flag active template tags means if the user has access to the login with Facebook feature, and it's not turned on for every user, display, in this case, a little alpha-only message so they know not to get too excited and start tweeting already. One very useful feature flag that we built quite early on, which served us really well, was a feature flag for putting the entire site into read-only mode. And it turns out, it's incredibly useful if you're working with a decent-sized code base, because it means that you can pretty much freeze your site in time, do a whole bunch of maintenance activities behind the scenes, and then unfreeze it without ever having to take the site down. And Andrew will be talking later on about a trick that quite a big trick that we pulled off with this. So read-only mode, you turn the feature flag on, a couple of things happen. You get this yellow banner on every page on the site, and the login button disappears. And we also, our authentication middleware actually starts ignoring your login cookie. So even if you'd logged in already, we'll ignore the cookie and pretend that you're logged out. In Lanyard's case, you cannot make any modifications to the site. You can't do anything that triggers a write if you're not logged in. So by just forcing the user into logged out mode, they were unable to make any changes, and we could guarantee that the site would stay in read-only mode. Likewise, our mobile APIs started ignoring the auth tokens, so the mobile apps behaved like the user was logged out as well. While you're in this state, you can do all sorts of things. You can clone the database, do all sorts of things to the database, switch over from one cluster to another. You can do quite wide-ranging maintenance tasks. And in fact, Andrew later will be describing how we moved from MySQL running on EC2 to Postgres running on SoftLayer with, I think, 20 minutes of read-only mode and no downtime at all. So you can pull off some pretty neat tricks with again, just a simple feature flag. Now, Eventbrite's approach to feature flags is quite different. Eventbrite uses a piece of open software called Gargoyle, which was released by the team at Disqus, the online commenting system. And unfortunately, with all of this stuff, it's quite hard to find decent screenshots. But this one demonstrates that Disqus has switches, and and you can set up a whole bunch of different properties on those switches. So rather than just saying this feature flag is available for this user, you can say, and in fact, these are all examples of things Eventbrite do. You can say this feature is available to these specific users or anyone who's a member of staff. This feature flag controls. This is only turned on for these particular events, so it's an event-related feature, or these organizers. We use it in our API, so we can turn on specific API endpoints for specific API keys. We can feature flag by country based on IP address. So if you're in Germany, you get some subtle variant in behavior. And we can even use it for those TLDs that Nathan was talking about. And to show you how flexible Gargoyle can be, and that flexibility does come at a cost, this is the entire implementation of a rule set saying, okay, we want to be able to set conditions on a switch based on your country. And all you have to do in Gargoyle is subclass condition set, give it a storage string so you can store the country that you care about, a can execute method that says, I can be, this condition can be applied if you have an HTTP request. And then you have a get field value that says, if the field is country, return the country attribute from the request, which is previously populated by a piece of middleware. You register that, and straight away you can start assigning rules to individual feature flags where you say, if the country is Germany, this flag should be enabled. There are a whole bunch of gotchas if you're working with feature flags. One of the most important to test against is looking out for unexpected flag combinations. It's quite, given the amount of code that you can end up hiding behind feature flags, there's always a chance that two feature flag combinations you hadn't thought of might lead to weird behavior. So generally, it's a good idea to try and keep the things that are affected by feature flags as separate as possible. And if they are going to overlap, make sure that you QA things thoroughly before you release them. Old feature flag code can get really ugly. Each of these things individually, it's an if this, do that, else do this. It's relatively easy to read. But over time, as you accumulate more feature flags, your code base can grow huge numbers of branches. So it's a very important, once a feature is live and you're sure it's going to stay live, that you strip out all of the feature flag code for that. And that's just generally good practice. And then the last one, of course, is performance, where if you think about it, anytime somebody requests a page of your website, you're doing a whole bunch of these feature flag checks. And so you can end up doing, if you're not careful, you'll end up doing a few, like 3 or 4 database queries per page view on your site. Gargoyle has a few things in place to help with performance. It's quite aggressive with caching. It'll cache things in local memory in the Python process for up to 30 seconds. It'll fall back on an external cache after that. But even with all of those caching layers, we found that at Eventbrite scale, a huge amount of our network traffic, our internal network traffic, was straight up memcache calls to load feature flags out of the cache. So we ended up putting a small memcached instance on every front-end web server just to host a copy of the feature flags, so at least that network traffic was on the local box and wasn't going out over the network. Turns out a lot of companies use feature flags. This is quite interesting. This is the only screenshot I could find of Facebook's feature flag mechanism, which is called Gatekeeper, and apparently allows, I think they've extended even more now. They can flag features to people who've liked a certain thing, or who are employees, or have a certain browser, or a certain age, or shoe size, or goodness knows what else. And back in 2012, let's just cut off there, they were doing over 500 million gatekeeper checks a second, and that was a couple of years ago. So you can imagine that they're doing way more than that now. So this quite neatly illustrates that you can scale feature flags to any scale that you like if you're sensible about the way you architect them. So feature flags, once you have them in place, they're kind of a Swiss Army knife. They become something that you end up hanging all sorts of other functionality off. At Lanyrd, we use them to turn on features for some of our paying customers. So we didn't even need a payment system for this initially. We could invoice someone, they paid us, we flipped on a feature flag, and they got extra capabilities for their events. And at Eventbrite, we've actually been building an entire A/B testing framework on top of our existing feature flag mechanisms. So once you have this relatively thin abstraction, there's a whole bunch of interesting stuff you can start building with it. So really, the takeaways from this are you should use feature flags. If you're building pretty much anything at all, it's worth getting feature flags in there early on and starting to lean on them. Don't use long-lived branches. Go with, get your code into core and use feature flags to turn it on and off. The ROI on them as a feature is pretty ridiculous. The amount of effort taken to get them up and running is tiny, and you will derive enormous value in terms of improved iteration speed, ability to just get code in front of human beings. And if you are going to implement them, Gargoyle is a pretty decent standalone open source package, which will get you up and running very quickly. Or if you decide to roll your own, it's really not a very complicated thing to build, and it can be quite fun to get into that and come up with the exact system that you want. And I've got 10 seconds left, but I think there's a question at the back. Thank you very much. I wish you'd told me that half an hour ago. So Gutter, yeah? Mm-hmm. Oh, nice. Okay. So Don't use Gargoyle, use Gutter and Zookeeper then. Awesome. Okay, thank you very much.